Now we're going to look at something that I think is pretty cool. I use this pretty often, and especially when I'm making macros that do things, but generally lets me manipulate output so that I can get what used to be a bunch of tables down to a few numbers. And so before we do this, we're going to actually analyze this data by gender using a similar model to what we did before. And we haven't really been paying any attention to what the results say. But here we have initial systolic blood pressure and initial diastolic blood pressure. And we can see there's an increasing trend here. Our estimate for systolic blood pressure is 0.407 for everybody combined. Now what we'll do actually is look at creating those two models by gender. So before I do that, anytime we use a by statement in SAS in a procedure, we need to make sure the data is already sorted by that variable. So I'm going to sort the data by gender, and then I'm going to run this analysis, which will basically give me two results, one for males and one for females. And you can see here we have GLM for gender male. We can see that the parameter estimate's about 0.46, and here's our fit plot for the males. And our parameter estimate for females is a little bit lower at 0.35. And here's the plot for our females. Now let's go back and talk about this command line ODS output. So what we did with this ODS output statement is we asked for two data sets. We asked for the parameter estimates table to be stored into a data set called PARMS, and the fit statistics table to be stored into a data set called FIT. So it's very similar to ODS select, but it has this equals part because we're storing this particular thing into a SAS data set. So this is very useful, and you might want to think a little bit about why this is so useful. SAS gives us a lot of output sometimes, and if I wanted to look at a number of different models, maybe I don't really want to look at 300 pages of output or even 20 pages of output. I would rather see one table with a summary of what was most important in that output. I can then go to the full output when I need to get more details. So here, what we want to do first is maybe look at these data sets. Before we do that, we'll look in the log file and just see what it says. That it says the dataset work.fit has 2 observations and 6 variables. The dataset work.parms has 4 observations and 7 variables. So first thing we're going to do is view these data sets. We're going to create 2 different prints, one of the dataset PARMS and one of the dataset FIT. We're going to put both of these in one PDF file called ODS Basics ODS Output. We'll come back and run the ODS PDF part later along with all of the escape character and PDF statements. What we want to do really now is go through this as if you were me, and how did I do this to begin with. So the first thing I really want to do is just do a quick print of the data equals PARMS. And so what I see is that I have a row for males that has the intercept, a row for males that has the slope, a row for females that has the intercept, and a row for females that has the slope. And then if I do the same thing for the data equals fit, you'll see that we have a row for males that has the R squared, the CV, the root MSE, and the dependent mean. So if we look back up here at this output, we've exported this table. Now it doesn't look exactly like that table. SAS will do its best to try to tell you what's going on here and do what it can to convert information. Plus we had the male and female, which is one of the reasons why it doesn't look exactly like what you see here. It has to combine the by information and get one output of parameter estimates and one output of fit statistics, even though we ran 2 different models. So the parameter estimates was the other table that we have. So here's our parameter estimates, and the same thing for the fit statistics. So we want to clean these data sets. My goal here is to end up with a table that only has a few pieces of information for males and females. So let's look at what we've done here in our code. We've done data parms. The retain statement here is being used to reorder variables. So I'm asking for gender to come first, the estimate to come second, the standard error, and prob t. Then I'm pulling in data from the dataset parms, and I'm saying if the parameter equals intercept, then delete. So this is saying go through each of the observations in the data set, and if the observation in the data set says the intercept for the parameter variable, then delete that row. So I'm getting rid of the intercept rows for both variables. But you can notice they're quite different, so it might not be something that I want to do in practice, but here we're just illustrating the idea. And then I'm going to drop some variables that I think aren't really useful. Now that I know I only have the slope, I don't need to see systolic blood pressure here. Now you might, if again you needed to know which variable you were using, but we're going to assume that we know that we're using the variable systolic blood pressure here. And we're getting the estimate. We're not getting the dependent variable, so same thing. We're going to assume that we know diastolic blood pressure, and we're going to drop the t value. So we're going to keep the estimate, the standard error, and the prob t, and gender. Dependent, parameter, and t value are asking, we're going to drop them. So drop and keep, which is the alternative to that, work on variables, and if works on observations. So keep that in mind. If we wanted to use a keep statement instead, we could get the same results by keeping gender, estimate, standard error, and prob t. So I'm going to run this to clean that data set. Check our log file really quick, make sure it seems like it worked, and then print that data equals parms. Now I overwrote that data, which is dangerous, but I knew that I was working in my work library anyway, and the worst thing that would happen is I would have to rerun the code to get the dataset parms if I messed it up. So now I've reduced that to just a little bit of information, what we're considering to be important right now. And then here we have data fit, set fit. We're just going to keep gender, r squared, and root MSE. You can see, again, the fit one wasn't very complicated, but it does have a few things, the coefficient of variation and the dependent mean that maybe we're not interested in. We're not interested, again, in the dependent variable, so we're just going to keep gender, r squared, and root MSE. So we'll run that data step, and then we will run this print. And so we can see we just have those two pieces for the genders. And so finally, we're going to merge these two tables together. So we're actually learning quite a few pieces of SAS code that you may not be completely comfortable with, but we're hoping that you'll get the idea here at least, and it's not too difficult. So we're creating a new data set called out. We are again reordering the variables, gender, then r squared, then the estimate, the standard error, then the prob t. We're going to merge the two data sets, parms and fit, by gender. So gender identifies which row goes where. Sometimes you might merge by an ID variable, but you have to have a unique variable or a combination of variables that uniquely identify how these observations are going to be merged together. It would need to be sorted by gender first, but these clearly are the same, male, female, male, female. So I'm going to submit that data step. Again, we'll check our log file just to make sure it seems to have worked, and then we'll print that data set. Here I've asked for the no obs option to clean up this table so it doesn't show this observation numbers on the left. So there's my nice clean table that has just a few pieces that I might think are important from that full set of output that we generated. So now we'll put all of that into an ODS PDF file just for having the output all in one place. So you can see, just gives us a little bit of an outline of what we did there.